Hi there, today a quick look at those two LED lamps from Poundland. And because in my country you can get Poundland items, but they are sold under a different brand, basically a different small store. And those piqued my interest because this one was discounted for something like 60 pence or three-quarters of $1. And this one was full pan, but still it has some features, and I was wondering how good it is, how efficient it is. And what's weird, because I presume that here is only small LED, and it does say that it has AAA included. So maybe I will be able to use those for another project. Just wanted to take a look inside and see exactly what kind of LEDs are inside. Let's start with this one. So the premise basically of this one is it's basically a lamp where you would pull on the cord to turn it on. But what's interesting, the battery are in the set. Let me try again. So as you can see, those it doesn't give you a proper clean light source, but as you can see, it looks a little bit discolored, but from a distance it's perfectly fine. So those kind of switches, well, they cost about £1 if you buy them separately. So that's really interesting that they put something like that inside here. Let's take this apart quickly. So firstly, let me remove the batteries here. The lamp was so cheap. Those are presumably standard 0% mercury or cadmium, standard zinc batteries, so not really alkaline. Still, they have some real courage in the way they are selling those. If they just put them on the shelf, and presumably those batteries were in some storage for at least a year. So that's really interesting. They are not expecting them to leak out. Let me just remove, those are 3 screws here only. And let's take a look inside. So this is only a cap. And here we have a LED. And what's interesting here, they went ahead and built basically a board. And presumably, let me just take a quick look here. Presumably those huge pads are for heat dissipation of this LED, which it's really great. I will try to measure the current using those batteries in a moment. Let me take a look at the resistor they are using here to run this. It's 8R2, so 8.2 ohms, which is quite a low value, for especially considering that this size of the resistor, I don't know, it's maybe a 1/10 of a watt. And the mechanism they are using here, so as you can see, there is a little bit of twine around this thicker one, and they are using basically a hacky solution with a little bit of plastic around this, and they put the actual switch in here, which that's a fairly common switch, especially for those cheaper things. You would be looking normally here at a switch that it's actually a pull switch. So they basically went with a better solution for a pull switch that would be much more expensive. So, well, the props to them, but I won't be able to basically use this for any of things I want. But this LED looks interesting. Let me measure the current over here. I replaced the batteries with a little better ones, and if I measure the current charging the switch using my meter, about 120 milliamps, so that's fairly good. But I'm a little bit worried about this resistor, but let me show you something. If I measure the batteries themselves when the power is on, measure the volts here, it's roughly 4.46, let's say. And measure the resistor, the drop on the resistor, sorry for shining the light at you, but there's basically no other way. It's about roughly drop of 1 volt, and the voltage on the LED itself, it's 3.13, so 3.1 plus 1 volt roughly, it still isn't 4.5. So basically what they are doing here, they are using the flimsy wires to as a, let's say, resistive load, basically to limit the current. Also I noticed that due to the fact that the internal resistance of those batteries, it causes them to drop the voltage from 4.7 total, because they are fairly new, to 4.5. So and in the flimsy wires provide additional resistance, and this switch probably can't carry a lot of current. But let me check this resistor. What would be the voltage on this? They also come with this piece of paper for making calculations, so it's roughly drop of let's call it 1 volt. It's a little bit more, but let's go with that, times 0.120 milliamps, so 0.12 amps. So the wattage that this resistor is dissipating is roughly something like 0.12, but watt. But if that's a little bit more than 1 volt, I would call this, let's call it 1/8 of a watt. And I think that this resistor is just barely capable of delivering that kind of heat dissipation. So they are using those huge pads to help with that. But I'm not exactly sure if that would mean a longevity of this resistor and this LED, but it should be fairly okay. You can always add a bigger resistor, I mean with a bigger resistance, so that would be also a good solution for that. But unfortunately I cannot use this as a pull switch. So let's try and look inside this other LED. This light has a much better packaging. If the materials used are a little bit better. It's also clipped in here, and it was more, let's say, more expensive. It's still £1. So it has a strap that goes around your head, presumably, or any other part you like. But I guess it's head sized. It doesn't have let's see if it can be angled, but I don't see a facility for that, so that's a no. But you can open it to put in batteries. Let's try that. There are no rows for the batteries, but they should be able to fit just fine. It's a very tight fit. So let me try and shine it. Okay. So we have 2 brightnesses and flashing mode. The thing is, if you cannot angle this, because you would presumably be wearing this like that, yeah, with the button on the bottom. If you cannot angle it, it's hard to use it in a dark environment. Oh, it goes off, so yeah, it's hard to use this in a dark environment because you presumably want to work on something, so it has to be angled just a little bit downwards. But let's take a look inside. Let me remove the batteries and disassemble this. Okay, batteries are gone. Let's start with removing this main plate. It probably helps with heat dissipation. So the whole battery connectors come out also, along with the LED. And looking at the front, here's our button. Here's our resistor and the main chip, presumably, that drives those LEDs at the different modes. Here are the 1, 2, 3, 4, 5, 7, 8, 9 LEDs. For convenience sake, because that's basically the same power supply, 4.5 volts, I put the batteries in the other lamp, and here we have the high mode. That's, let's say, 220 milliamps, the dim mode 70 milliamps, and the blinking mode, that's probably a high mode, but pulse width modulated around half of the maximum load. Let me check the resistor, the drop on the resistor, and by that I mean how much this is being used during the operations. Well, 0.5 volts, and in a dim mode a lot less. So basically what happens here, the little chip is changing the voltage on the output, presumably. So I would guess on the output of this it's something like 3.5. Let's see that those tracks over here should lead directly to the LEDs. Yeah, that's quite interesting, because if you can see on the voltage meter, that's 2.2 volts at the moment. Let's go back to the high mode. And almost 3 volts, so that's presumably the voltage that those LEDs are being driven at. If I go to the blinking mode, it's basically flashing in my eyes. So yeah, let's call it at 1.9. So if I take a closer look over here, that's exactly the tracks that are leading to the LEDs themselves. So that could mean that this little chip is dropping the voltage basically to something like 3.5 in the high setting, and I guess it was 2.4 or something like that in the low setting, which could also mean that it could be also used to drive those LEDs from this smaller voltage. And let me just try this, because if I connect this setup to the 3 volts, so over here, that should be about right. Let me try this again. As you can see, it also works at 3 volts. So just remove one of the batteries and put a short in place to connect the sides, and let's see what kind of voltage we have on this. Almost nothing in the low setting, and in the high setting, yeah, it's fairly low. Maybe I don't make a good connection here. No, it is very low. And let's check the high setting, the voltage on the output, 2.7. So it's far lower. Presumably it would use a lower current. Let me just quickly check that. So it was 26, 27, let's call it 30 tops, if it was making a good connection. So you are reducing the amount of light it gives out, but also the amount of batteries you will use for that. Presumably you could also drive this whole board using standard lithium-ion battery, or even 5 volts from USB power supply, because 4.5 from this isn't as different as 5 volts. It should be roughly fine. So running this from 5 volts from the power bank, let me turn it on, and looking at the milliamps, that's quite a lot. It came to the temperature and it's still cool to touch. It's really good that the panel has this back plate, and the light is really bright, but you won't get much more efficient. So the current drawn by this whole panel assembly is over 1.5 times as much, but you won't get as much efficiency of the brightness, and then you would be normally using those 120 milliamp or 220 milliamps. So it doesn't get as bright as you would expect using this much current. So it's not as efficient. It would be a better idea to actually drop some of the voltage, because it may reduce the life significantly. But that's a really good panel. I really like this design. You can always connect directly here with something like 2.9 volts and drive it directly, and it would happily run at 200 milliamps. And I think it's a neat thing. So from all this, and I will also probably check how does it look in the darkness. Okay, here we are outside, and
it's exactly the problem I was mentioning. On your forehead, it's barely when you're working on something, it's barely visible. It's basically on the edge of the light, and it shines all above, very high, but doesn't shine on your hands when you're working on something. So it's basically in the half shadow usually. And last but not least, here is the light. Let me just find the focus. Oh, it's much better. So it doesn't really shine that brightly, but you should be able to see quite well. The camera can't get the focus on this one, but you should be able. Well, let me try again. You should be able to see quite well and quite enough from a distance. It looks quite attractive, like a normal light, and it just is something that you could use in your garden. So that's all, guys. Thank you for watching. I hope you enjoyed.